Inverse functions undo what was done by the original function. For example, if f of x is equal to x squared, then the function will result in squaring the x values. To undo this, you will have to square root the x values. In other words, the inverse function of x squared is plus or minus root x. So if we look at these two functions, if our original function is y equals x squared, given a table of values, obviously substituting in our x values to get our y values, we get values of 4, 1, 0, 1, 4, 9. The inverse function, if we insert these same x values into the function, substituting in a negative 2, can't take the square root of 2, so this does not exist. Does not exist. Same with negative 1. Substitute 0 in, we get 0. Substitute 1 in, we get a positive or negative 1 because of this minus in front of it. This would be plus or minus root 2. We'll just give the approximation value of that value, so when we go to graph it, we approximately know where it is, so 1.41, and plus or minus root 3, which is a 1.73. And I'm going to do one more point at 4, just because this works out. Square root of 4 gives me plus or minus 2. All right, so now if I compare these two graphs, I'm going to sketch these two graphs. So either use two different colors or a dotted line and a solid line. I'm going to use my dotted line for my quadratic function. Just in the scale here, everything's going up by 2. So I'm just going to, I want it to be fairly accurate, so I'm just going to plot some points here to get a fairly accurate graph. So I'm going to graph my original function as a dotted line, and then I'm going to graph my new function as a solid line. So 0, 0, that's still the same. This is going to be plus or minus 1, so that stays the same, and then we also have a point down here. Plus or minus root 2, which is approximately 1.41, so approximately here and here. Okay, at 3, oh sorry, that is, I am doing the opposite here. We're going to go 2, we get 1.41. There we go, that looks better. At 3, we get a value of 1.73, so a little bit higher. And then at 2, so we can kind of see what's happening here. We're kind of getting the same shape of graph, but something that is actually opening to sideways. All right, so this is the inverse function of our quadratic. So one unique thing about inverse function, imagine this is actually a reflection of one another. And it's obviously not being the y-axis or the x-axis. We actually have a reflection. I'm going to draw the line y equals x. And so if you can visualize folding this piece of paper on this line, y equals x, this is a mirror of this. So y equals x, this means the inverse function is a reflection of y equals f of x in the line y equals x. All right, so let's go even further down a little bit more. So an inverse function, an inverse is often thought of undoing or reversing an order, a position, order, or effect. If f is a function that maps x to y, then the inverse of that function will map to x. So for example, given the function y equals x plus 3, and in this function negative 4 would give me a y value of negative 1, negative 3 would give me 0, 0 would 3, 2 would give me 5, 6 would give me 9. The inverse of that in terms of points on a function is we're, instead of mapping x to y, these are going to be the inverse. So we're now going to map our y values to our x values. So the inverse function, what happens is literally the x and y values just switch positions. So my y values now become my x coordinates, and my x values now become my y coordinates. Okay? So that's the main thing to remember when we talk about inverses, is that literally our x and y values are switching positions, and it's a reflection in y equals x. Okay, so notation. What notation is used to figure out if we are talking about an inverse? Okay, so an inverse function, the notation we use is f of negative 1 of x. Okay, this should only be used when the inverse is actually a function. Okay, so if it's an actual function, so for example, a linear function to a linear function, both of these, this is a function, the inverse would also be a function, so we could use this notation. The other notation you might see would be x equals f of y. Okay, this can be used if the inverse is a function or not a function.